All right, these are examples of solving compound inequalities. And for each of these compound inequalities, you're going to be asked to solve each compound inequality. You're going to show all appropriate steps, and then you get to indicate the solution in graphical form and also in interval notation. So let's go ahead and look at number one. So here is number one. So we have this compound inequality. So notice the idea that compound inequality in this case is that you have this statement right here that has two inequality symbols in it. So basically you're saying that this expression right here, 3x plus 7, has to be greater than negative 5, and at the same time, it has to be less than or equal to 22. Now, as you read it from left to right, it basically says this: negative 5 is less than this expression, and this expression is less than or equal to 22. So whenever you see a compound inequality that looks like this, that's written in this form, it is so much easier to solve this inequality by obtaining the variable in the middle by itself. So you're trying to find all the values of x so that when you multiply it by 3 and add 7, that number will be less than equal to 22, and at the same time will be greater than negative 5. All right, so the best way to do that is to think of this this compound inequality with just this part first. So if this was here, if all you saw was this, you all know that to solve for x, you would have to subtract 7 from both sides, right? But remember, though, that this is a compound inequality, so there are three parts to this. You have this part, this expression here, and then this numerical expression as well. So you have to subtract 7 from all parts, just like this. All right, and then combining like terms, you have negative 5 and a negative 7, which is a negative 12, is less than 3x. Positive 7 and negative 7 is 0. And that's going to be less than or equal to, and then 22 minus 7 is 15. All right, so we're almost there to where we can actually determine what are the values of x so that this compound inequality is a true statement. So if all I had was this right here, then you know that to get x by itself, since I'm multiplying by 3, you would have to divide both sides by 3. But in this case, you would have to divide all parts by 3. So I'm going to go ahead and just rewrite this over. And so now we're going to divide this by 3, this by 3, and this by 3. So we have to divide all parts by 3. And then simplifying, I get negative 12 divided by 3 is a negative 4. And that's going to be less than 3 divided by 3 is 1. 1 times x is x. And that's going to be less than or equal to, and then 15 divided by 3 is 5. And so I found the solutions to this original compound inequality. So any real number between negative 4 and 5, including 5, is going to be a solution to this inequality, this compound inequality. No other number, so if a number does not lie in here, and also keep in mind, see this, there's no equal sign here, so negative 4 is not a solution. But any real number between negative 4 and 5, including 5 because of the equal sign, is going to be a solution. So these are your solutions right here. So you found your solution. Now you want to write this in graphical form. So in graphical form, this is easy to graph. You're just going to graph every real number between negative 4 and 5. So here's negative 4. Here is 5. All right, now I know that since there is no equal sign here, that I'm going to have to put an open circle at negative 4. Negative 4 is not a solution. But I do know that 5 is a solution to this compound inequality, so I need to put a closed circle. So we have this, and then we're going to shade it in. Now, if you wanted to, you could, instead of using open circles and closed circles, you could use parentheses and brackets. But just be aware that it needs to look like a parentheses. So make that look like a parentheses. An open circle corresponds to a parentheses, and a closed circle corresponds to a bracket. You got to make sure it looks like a bracket. And then you got to shade in every real number between them. All right, so there's the graph. So this would be the graph. So either or is fine. All right, and then the interval notation, you're just basically, so I'm going to put this as interval notation. So for interval notation, you just read from left to right. So negative 4 parentheses, so it's basically this right here. Negative 4 parentheses all the way to 5 with a bracket. All right, so that's your interval notation. Now, before we go to number 2, I just want you to realize that these statements that look like this, where you have a compound statement that's written as a sentence form like this with 2 inequality notations, this is really an AND statement. So basically this is saying that 3x plus 7 has to be greater than -5, and at the same time 3x plus 7 has to be less than or equal to 22. So basically what you're saying is this. You're saying, now here's a second approach if you wanted to use it, but most students, when they see the statement written like this, they'll solve it this way. But the second approach is to change it to an AND statement. So write it as an AND statement. And so basically you're going to say -5 is less than 3x plus 7. And at the same time, so if you're gonna write it like this, you need to use the word and. So don't leave that word off, because then you're going to lose some points, because mathematically what you're saying is that -5 is less than 3x plus 7, and at the same time 3x plus 7 is less than or equal to 22. So that's not an or statement, that's an and statement. This right here and this right here are going to satisfy this compound inequality. All right, so then you would solve each linear inequality individually. So let's go ahead and subtract 7 from both sides. See, it looks familiar, right? The subtraction 7 right here. Look, right here. So you're subtracting 7 from both sides. And so I get -5 and a -7 is a -12 is less than, this is 0, 3x. To get x by itself, I have to divide both sides by 3. And so I get -4 is less than x, which means that x has to be greater than -4. Over here, if I solve this compound inequality, subtract 7, this linear inequality, subtract 7 from both sides, and combine like terms, I get 3x is less than or equal to 15. Divide both sides by 3, and then simplifying, 3 divided by 3 is 1. 1 times x is x. I get x is less than or equal to 5. But remember, that's an and statement. So when you think about an and statement, you think of intersections. So if you're going to graph each of those individually, what you have is this. So here's -4, open circle going to the right. And then here is 5. Make sure you put 5 in the correct place according to -4. So 5's to the right of -4. Closed circle going to the left. And from our previous experience, we note that this and right here means intersection. And so the solution to the statement here has to be where those two graphs intersect. And so your graph then, you're going to put this on one number line. So your graph will be from -4 to 5, open circle, closed circle, and shade in everything between them. And then your interval notation will be parentheses -4 to 5 with a bracket. Okay? All right, but just keep in mind that if you rewrite this as two statements, you need to put the word and. If you leave the word and off, you're not going to get full credit, even though all of this right here may be correct because you left the word and off. So you need to determine, when you rewrite it like this, you need to use the word and or are. In this case, it has to be and, because this is an and statement right here. -5 is less than 3x plus 7, and at the same time, 3x plus 7 has to be less than or equal to 22. Okay, so number 2. So let's do number 2. So number 2, I have this compound inequality. 2 is less than 4 minus x is less than 7. So similar to the previous one. So I've got to find the solutions of x, the values of x that will make this compound inequality a true statement. All right, so what values of x will make this expression greater than 2 and at the same time less than 7? So we're going to go ahead and subtract 4 from both sides. So I get 2 minus 4 is 2, -2 rather, is less than, this is 0. A negative x, now be careful, that's a negative x, is less than 7 minus 4 is 3. All right, now I'm going to go ahead and rewrite this negative x like this. -2 is less than -1x is less than 3. All right, so but remember, we're trying to get the value of the variable x by itself. So right now I'm multiplying by -1. The opposite, let me go ahead and rewrite this over. The opposite of multiplying by -1 is to divide by -1. But remember, whenever you multiply both sides or all parts of an inequality by a negative number or multiply by a negative number, you must reverse the inequality symbol. So you have to reverse the inequality symbol. The inequality symbol. All right, so we have negative 2 divided by negative 1. So basically this will be a greater than and a greater than. So that's how you're going to rewrite it. Since I divided all parts by a negative number, I have to reverse the symbol. So negative 2 divided by negative 1 is 3. So 3 is greater than now. And negative 1 divided by negative 1 is 1. 1 times x is x. And that's greater than, remember, see, whenever, you'll notice that whenever you see a statement written like this, all of the inequality point in the same direction. So less than, less than, less than, and then all of a sudden greater than, right? They're all pointing in the same direction. 3 divided by negative 1 is negative 3. So remember also that even though the statement is correct, we prefer to go from smallest to largest. So we're going to go ahead and rewrite an equivalent statement here, an equivalent statement. And so basically I'm saying that negative 3, so we're going to put the negative 3 first, and that's smaller than positive 3. Negative 3, so what this means is this. So if x is greater than negative 3, then that means negative 3 is less than x. That means that. This means this. And then here, if 3 is greater than x, that means x is less than 3. All right? So this is equivalent to this. And then once you write it like this, you know your graph. So the graph, you're going from negative 3, and notice there's no equal signs in either one. So we're going to put open circle or parentheses, does not matter. You could also do this instead, it does not matter. Parentheses, parentheses, just make sure it looks like a parentheses though. Okay, make sure it looks like a parentheses. And then interval notation, you always go from smallest to largest. So interval notation, you're going to say parentheses negative 3 to 3 parentheses. All right, so that was number 2. All right, let's look at number 3. So number 3, we have this statement. So this compound inequality. We have negative 1 is less than or equal to 2x divided by 3 plus 5 is less than or equal to 2. All right, I do have a fraction, but what I'm going to do first is go ahead and get rid of this plus 5 right here. So I'm adding 5. The opposite is to subtract 5 from all parts. This part, this part, this part. And then when I combine like terms, negative 1 plus and a negative 5 is a negative 6. Is less than or equal to, this is 0. So I get 2x divided by 3 is less than or equal to, and then 2 and a negative 5 is going to be a negative 3. Now at this point, my LCD is 3. So I'm going to multiply all parts by 3, meaning this. So meaning that, let me go ahead and just rewrite this over. Negative 6 is less than, I'm going to leave some space here. 2x divided by 3 is less than or equal to negative 3. So I'm going to go ahead and multiply all parts by 3. So times 3, times 3, times 3. Okay? And so now when I go ahead and do this product, remember the whole point of multiplying by the LCD is to get this fraction here to be a 1. And it will now, because 3 divided by 3 is 1, 3 and 3 is 1. 3 times a negative 6 is a negative 18. It's less than or equal to 1 times 2x is 2x is less than or equal to negative 3 times 3 is a negative 9. And then dividing both sides by 2, I'm going to just rewrite this over. Dividing both sides by 2, I get negative 18 divided by 2 is a negative 9 is less than or equal to x. 2 divided by 2 is 1. 1 times x is less than or equal to, and the negative 9 halves is a negative 4 and a half. So I'm going to just go ahead and write it like that. All right, and so then your graph, you're going to say negative 9, negative 4 and a half, and both of those have equal signs, so it'll be closed circle or brackets, and then shading everything between them. And then interval notation, you always go from smallest to largest. So the interval notation, you're going to say bracket -9, -4.5, bracket. All right, so that was number 3. Now, if you had a number line that looked like this, let's say this is -10, and let's say this is -3, -4, -5. I'm just putting something like that just to show you something. So we know that -9 is right here, right? So you can put a bracket, a closed circle in -9. -4.5 is between -4 and -5. So just make sure if you see this, that you put that -4.5 in the middle of -4 and -5, and then you just shade in everything between them. So just in case you had more numbers on this number line than we have here, just make sure you put -4.5 in the right spot. So -4.5 is between -4 and -5. All right, number 4. So number 4, we have this problem. So we have -7 is less than or equal to 3 minus 2x is less than 9. So I have this compound inequality, and I want to get the value, the variable x in the middle. So I'm going to go ahead and subtract 3 from all parts, since right here that's a positive 3. 3 minus 3 is 0. And so when I combine like terms, a -7 and -3 is a -10. It's less than or equal to, this adds up to 0, and 0 and a -2x is a -2x. It's less than, and then 9 minus 3 is 6. All right, now, just go ahead and rewrite this over. Okay, so the next step, remember, is to get x by itself. So we're now multiplying x by -2. The opposite is to divide by -2. But remember, whenever you multiply or divide an inequality by negative number, which I am, you're going to have to reverse the symbol. So this symbol, these two symbols I'm crossing out, they now, since I'm divided by a negative number, I now have to reverse those. So it'll be greater than or equal to, and then greater than. And so now I get -10 divided by -2 is a -5, is greater than or equal to -2 divided by -2 is 1. 1 times x is x, and that's going to be greater than, and then 6 divided by -2 is a -3. But remember, we tend to put these in order from smallest to largest. So -3 is, okay, I did do an error there, I think. Let me go back and make sure. Oops, right here. So here's the error. So negative divided by negative is a positive. All right, so we need to put this in order. So that's a positive here. So if that was a negative, that would have been an error, right? Because -5 is not greater than -3. But 5 is greater than -3, so that's a positive right here. All right, so rewriting this, I get -3 is less than x is less than or equal to 5. So I always go from smallest to largest. And then now I can graph very easily. So my graph will be any real number between -3 and 5, not including -3. So notice the open circle because there's no equal sign, but including 5 because of the equal sign. So there's a closed circle, and then shading everything between them. Your interval notation, you always go from smallest to largest. So you have to put -3 first, and you have to put 5 last. No parentheses and brackets. So parentheses corresponds to open circle, bracket corresponds to the closed circle. So remember, that means that closed circle means that 5 is a solution. Open circle means that -3 is not a solution. You know that because there's no equal sign here, and there is one here. All right, so that's number 4. Okay, let's go to number 5. So number 5, we have x plus 1 is less than 9, and, so there's that and statement, 2x minus 1 is greater than 7. All right, so remember, whenever you're dealing with an and statement, so to solve this compound inequality, this and this, you're trying to find all the values for x that will make this inequality and this inequality at the same time. So you're going to find solutions that satisfies both at the same time. Okay? All right, so we're going to solve each one individually. Now, when we do this, remember the and statement corresponds to intersection. So we're going to be looking for an intersection. So this one's easy to solve for x. All you have to do is subtract 1, so we'll get x is less than 8, right? Over here, oh, and let's go ahead and well, let's finish this one. So we're going to add 1 to both sides. So I get 2x is greater than 8. Divide both sides by 2. I get x is greater than 4. All right, so the solutions to this inequality right here is any number that's less than 8. The solution to this inequality right here, this linear inequality, is any real number greater than 4, right? And so what I want to do, though, is find out where do these two linear inequalities share the same solutions. So to do that, let's graph each one individually. So here's 8, open circle going to the left. Here is 4. Make sure you put 4 in the right place. 4 is to the left of 8. Open circle going to the right. And the intersection would be where those two overlap. And so your graph, your solution then, will be any real number between 4, notice the open circle, and 8, notice the open circle. So 4 and 8, open circle on both. So any real number between those two. And then the interval notation, you're going to say parentheses 4, 8 parentheses. All right, so that was number 5 rather. Okay, let's look at number 6. So number 6, you have an or statement this time. So x plus 1 is less than 2, or 2x minus 1 is greater than 8. All right, now remember, the and means intersection, or means union. So when solving an or compound inequality, you're finding the solutions that satisfies either one. So the solution that satisfies this one would be a solution to this whole thing. A solution that satisfies this one would be a solution to this whole thing. So the solution to this R compound inequality is the union of all of these solutions. An and statement is the intersection of these solutions. So where do those two solutions, whether those two inequalities overlap in terms of intersection, in terms of solution. All right, so for the or statement, remember or means union, so we're going to go ahead and subtract 1 again. So I get x is less than, in this case, 2 minus 1 is 1. And then over here, so any real number less than 1 is the solution to this one. So I already know, by the way, I already know the solution, one part of the solution to this whole compound inequality. That's this one. So any real number less than 1 is the solution to this whole thing, because that's the or statement. Over here, if I add 1 to both sides, I get 2x is greater than 9. Divide both sides by 2. I get x is greater than 4.5. So any real number greater than 4.5 is a solution to this compound inequality as well. So these are your solutions. So any real number less than 4 and any real number greater than 4.5. But you want to, sometimes these will overlap. So you need to look at each one individually. So here's the way I would do this. I would graph each one individually. So here's 1, open circle going to the left. Okay, then we do the next one. Here's 4.5, open circle going to the right. And so my final graph, you're going to put all this on one number line. So anything that's shaded is a solution. Anything that's shaded is a solution. So you're going to say 1 going to the left, and then you're going to say 4.5 going to the right. So there's your solution. So this compound inequality, your solutions are made up of two intervals. So this interval and this interval. Notice this one came from here, this one came from here. So that's the idea of that union. So any solution of this is a solution to this whole thing. Any solution of this is a solution to this whole thing. Now in interval notation, here's how you have to write this. You're going to see this arrow is pointing towards negative infinity, and this is pointing towards positive infinity. Always go from left to right. So I'm going from negative infinity. Whenever you use infinity, negative infinity, it's always parentheses. So negative infinity to 1, parentheses, because of the open circle, union. So you see the idea of union here, union, and then parentheses 4.5 to infinity. All right, so that's number 6. All right, number 7, we have an or statement again. So let's look at number 7. So remember, or means union. So you have negative y plus 5 is greater than or equal to 9, or 3y plus 4 is less than negative 5. So so remember, this is an OR statement, so OR means union. So any solution to this is a solution to the whole compound inequality. Any solution to this one is a solution to this whole thing because of the word OR. So your solution would be whatever satisfies this or whatever satisfies this. So here's the idea of that union. All right, let's go ahead and solve for y over here. So I'm going to subtract 5 from both sides. So I get negative 1y. Sometimes it helps to rewrite negative y as negative 1y. This is 0. Is greater than or equal to 9 minus 5 is 4. All right, let me go ahead and rewrite this over. All right, now remember, I got to get y by itself, right? So I have to divide both sides by negative 1, the coefficient of y. But remember, since I'm dividing both sides by a negative number, I have to reverse an equality symbol. So this greater than or equal to becomes less than or equal to. So make sure you cross it out and put the correct symbol. So negative 1 divided by negative 1 is 1. 1 times y is y. So the solutions to this inequality would be any real number that's less than or equal to 4 divided by negative 1 is a negative 4. All right, so any real number less than or equal to negative 4 is a solution to this, and hence a solution to the whole thing. Now let's find this one. There could be more, so we got to solve for this one. So subtract 4 from both sides. I get 3y is less than negative 9. Negative 5 and negative 4 is negative 9. Divide both sides by 3, and then reduce. 3 divided by 3 is 1. 1 times y is y. It's less than, and negative 9 divided by 3 is a negative 3. All right, so any real number less than negative 3 is a solution to this, hence a solution to this whole thing. But you have to look at each one individually to see if there's anything that overlaps as well. So watch at this. So here's negative 4, and closed circle going to the left, right? And then here's negative 3. Now be careful, negative 3 is to the right of negative 4, so make sure you put it in the right place. And then going this way as well. So remember, union means anything that's shaded. So look at what's shaded. So everything, see where they overlap? That's shaded, right? And even this part here that don't overlap, that's part of the solution as well. So anything I have like crossed out like this is a solution to the OR statement here. So your graph, you're going to put it as one statement. So don't say this is your graph. Your graph has to be on one number line. So you're going from negative infinity all the way to negative 3. So you're going to say negative 3, closed circle, going to the left. So this or this, when put together, is really this. That's the point I'm trying to make. So this or this, when you look at it together, is this solution right here. Okay? So that's the way you have to write it, like this. So that is your graph. Not this, but this. And then your interval notation, you're going to say negative infinity all the way to negative 3 with a bracket. All right, and then finally number 8. So let's look at number 8. So number 8, we have 2x plus 8 is greater than or equal to 5x minus 7, and 5x minus 3 is greater than 3x plus 1. All right, so let's go ahead and solve. Now remember, that's an and statement, so in the end, we're going to be looking at the intersection. So the solution to this compound inequality with the word and is the real numbers that makes this and this true at the same time. So it's got to satisfy both. It's not an or statement, that's an and statement. So what I'm going to do, since I'm going to go ahead and bring the 5x to the other side, just to remind you what to do when you divide by a negative number. So I'm going to go ahead and subtract 5x on both sides. So I get 2x minus 5x is a negative 3x plus 8 is greater than or equal to, this is 0, and you get negative 7. Subtracting 8 from both sides and combining like terms, I get negative 3x is greater than or equal to negative 7, and a negative 8 is a negative 15. I'm going to go ahead and write this over. All right, now remember, I've got to get x by itself, so I've got to solve this inequality, so that's what I'm doing here. So now I'm going to divide both sides by negative 3, but remember, when you divide both sides by negative 3, you have to reverse that inequality symbol. So greater than or equal to becomes less than or equal to. And so your solutions to this linear inequality right here would negative 3 divided by negative 3 is 1, 1 times x is x, would be any real number that's less than or equal to, and then negative 15 divided by negative 3 is 5. Now that's only for this one. But remember, that's an AND statement, not an OR statement. Okay, to solve this one, we'll go ahead and subtract 3x on both sides. And then combine like terms. 5x minus 3x is 2x. Minus 3 is greater than, this is 0. 0 plus 1 is 1. Adding 3 to both sides, I get 2x is greater than 1 plus 3 is 4. This is 0. And then dividing both sides by 2, and then reducing, 2 divided by 2 is 1. 1 times x is greater than 4 divided by 2 is 2. All right, so remember, that's an AND statement. So the solution to this compound inequality would be where these two overlap. These two inequalities overlap. So let's look at each one individually. So here's 5 greater than, less than or equal to. So closed circle going to the left. Here is 2, open circle going to the right. And this is an AND statement. Remember, AND means intersection. Intersection. So the solution to this compound inequality with the word AND would be where those two graphs overlap. And so your graph, then, on one number line, your graph will be between 2 and 5, 2 open circle, 5 bracket. So 2, 5, open circle, bracket, open circle, closed circle, and then shade in every real number between them. And then the interval notation, you're going to say parentheses 2, 5 with a bracket. All right, so that is the key to these problems on solving compound inequalities.